We're alive. February 22nd. A lot of twos in today's date. Before we start, let's take a look here. Oh, we have broken calculator. I'm not sure. What did I comment yesterday? I don't even remember what I commented yesterday. Let's take a look. I commented somewhere. Too slow. There's no way this question gets asked in an interview. Oh, actually, I thought about it later. It's not correct. You have to prove that going from y back to x, if it's an odd number, they have to prove that the best strategy is +1 and divided by 2. And it could be -1, which, I mean, if you think about it, it's moving away from the target. If you want to move towards the target, that is the only way to go. But anyway, okay, I have comment on that. I don't remember this. Just a bunch of people commenting on broken calculator. Anyway, oh, what are you doing? Click on current time. All right. I always have a new day, new week actually. Take a look. Longest word in dictionary through deleting. Given a string, okay, and string dictionary, okay. Find the longest string in the dictionary that can be formed by deleting some characters of the given string. If there are more than one possible result, return the longest word with the smallest lexicographical order. If there's no possible result, return the empty string. So what you're saying is you're trying to delete letters from the longest in the dictionary by deleting some character, like this one goes for apple. So we can remove B, C, A, and that will become apple. If there are more than one possible results, we're going to return the one with the smallest, okay? We're the smallest one. So basically we can just sort it. We'll have to sort it. How do we sort this? We have the first sort based on its length, and then if the length is the same, we're going to sort based on lexicographical. How do we do this? Is it even possible? Anyway, so this one will be A. All the strings in the input will only contain lowercase letters. The size of the dictionary won't exceed 1,000. The length of all the strings in the input won't exceed 1,000. So we have a small space, which means this one probably is n squared or n squared. All right, by just reading about it, I have no clue, zero clue, no idea. So what we need, all right, so basically we can count this. We'll run a counter on this. After we run a counter, we will know what letters it contains. And then we go through this like, and it doesn't contain M, so we don't have to consider this at all. But I think this only eliminated very little. Like for this, you don't even eliminate anything. That's interesting. So what we want is the longest string, all right? So what if we sort this based on size, and then sort, if they have the same size, we sort it based on lexicographical, and then we go from back to front. Probably shouldn't go from back to front, so we start a reverse, right? So the largest will be at the front, and the largest will be at the front with the lexicographical at the front. Okay, we worry about how the sorting might work, so we just check each one of them because it won't have 1,000. The first one I check just to see if we have. Oh, even if we have, it's not direct, because if the order is not right, then I don't think it's gonna work. Like if I have PAB, right, then it probably return an empty string. Just to take a look. Let's say the input, instead of we put AB here, and then this will return an empty string. Yeah, because we're okay. No, I mean, I prove my point, right? So it has to be follow the same pattern. You cannot. So it's not just taking the taking the counter. Right? Taking the counter is not going to work directly. So for this one, we're going to sort it. So the result I hope to have is apple, monkey. They have the same. Like the monkey has more. Monkey goes first. So it's going to be monkey, apple, monkey, apple, plea, and ale. So that will be the dictionary. All right. And in order to see if it works, so we can do, we turn that into a set, and then we do set and set a intersection. So the intersection has to be intersection. I don't. That's too much. Too many operations here. So there a way to determine whether apple is in this string? Yes, I think so. We can have 2 pointers. A is good. We move on, and then B is not good. We move on. We find the first P, move on. Find the second P, move on, and then find L. Yeah, I think we can use that. We can go. Yeah, I think we can find. Okay, so problem solved. We're gonna sort it first. Make sure that we can even, right? We can even turn this into a priority queue. We can make a custom class, and then we're going to determine how it's going to be compared. Because otherwise we have to sort it. Can we sort it? Can we sort it? I have no idea if it's possible. All right, let me give it a shot on the sorting part. So we have this. Let's give this a shot. We say A is this. I'm gonna also make another one. Let's say Beeple, right? And let's put. I want also an A call, right? So this is our this. So if we say sorted A and key equals lambda s, so the return value is going to be, we're going to sort first based on this and then based on this. Does this make sense? Apple, Beeple. Oh, I think it does. So, okay. So what if I say minus? Yeah, I think this is what you want. Okay, this might work. Let's copy it, what we have, and give it a shot. I think it might work. I'm not 100% sure, but let's give it a shot. Okay, let's delete the old ones. Come in here, give me the new ones. So first thing first, I can sort it in place. So d dot sort key equals lambda sto. Let's do this. Actually wrong. It's like this. I'm going to return two things. First is length, but we're going to do a minus length and do s itself. So now we sorted the dictionary. Now what we need to do is for a word in D, and then we just need to see if they. So we're going to run another function called contains. We have the s and word. So I'm going to try to see if the word contains in s. So I'm going to return a Boolean value. So we're going to have two pointers, 0, 0. And actually, I think we only need to have one. Yeah, I think we only need one, because we are going to just go through for, let's put in J and IB here. Oh, I don't even need, I think I just do letter in word, right? For letter in word, while SI is not equal to letter, we're going to go I plus equal to 1. Right? And then we keep moving I forward, and that has to be I smaller than len s. And so if it's not the same, we're going to keep moving. If it is the same, then the letter move forward. And then when do we get out? I'm going to check. I'm going to say if I equals len s, then we're going to return false. Should we? Hold on. it's not very straightforward. So if they're the same, we need to increment I still, and then the word end is not the same, so we just keep going once it's the same. Increment, letter increment, same, come out. So when it comes out, we need to check, right? So if everything matches, right, the last word, and then this matches by the same I plus. So when they come out, if they all match, then how do we determine? This is ridiculous. So if it doesn't match, let's check if it doesn't match. I'm kind of confused right now. If it doesn't match, I check on this. Does not match, I go to the end, and it does not match. So if we're gonna break, which means we have searched through our S, right? If we search through the S and then come out, if we do need J. So we need to know how many enumeration has done. All right, we're gonna return So we have two scenarios, right? One is a break. If it doesn't break, that means, so else, which means we, wait, is it? Oh my God. Else is when it breaks, right? I forgot. Oh, come on. I'm not in myself today. A break, if we, a for else. So if, no, for else is when this does not. Okay, so if a break, we don't need to go through. So else is going to be returned true. That means we finished the top. And we finished the top, and we haven't finished. Yeah, we finished the top first, which means it matches, right? So if it breaks, let's say it's the last one, and then we plus one, and then it equals, right? It equals and come out. Then it will not. We're going to do I plus equals 1 as well here. So this one we're going to return false. Yeah, I think this shall be right. So we're going to say if self.contains, if word containing s, we're just going to return word. If nothing, I'm going to return empty string. I'm not sure. This is a little bit confused. Like, which one happens first? So this is when I have exhausted S, but LE is still there. We have exhausted S, but LE is still there. That means there's no match. So I think I can just directly return false here. And when we can return true after the loop ends, because if we exhausted this, that means we have found the thing. So I don't think we need to enumerate. I think this shall suffice. All right, let's check here. This is S, and D is this. And the answer is apple. Now we have to take care of all this. Oh, and don't forget, I have to do this as well. All right, so with this, we can actually, like I said, I changed a little bit. I put AB here, and then this one becomes plea. And we're gonna do the same thing, but this is going to be ABC. A, B, C, and this one will return A. And I also want to make an empty. So it should be simple. Empty will be A. This one gives us an empty, right? If I understand it right, this will give us an empty. Okay, we're gonna have S, word, not word, D, and this is gonna be find longest SD. Run. I pass everything. Okay. It might work. Let's see. Wrong answer. Ah, it must be the matching. It must be the matching. Do we take a look? Expected AB, got BA. That is sorting. Let's take a look. It could be the, oh shoot. It could be the sorting issue. Say we need to have AB, so we got BA. Okay, not too big an issue. I think it probably is the sorting issue. Okay, multiple spaces after. Which one? Oh, here. All right, let's just comment this and let's check if D is as expected. No, D is not as expected. Oh, we is S underscore. Ah, it's a typo. It's S underscore. Try it again. Yep, we got it. We got it. Let's take a look. We are, ooh, a wide range. We are about the middle. Okay, yeah, done it. We first sort. And then we'll use, yeah, I think maybe using a, oh shoot, using a priority queue might be faster because we do, if it's a priority queue, then everything is either log n or n. I mean, initial heapify is on, and each time is on, o log n, and it might be faster. It might be faster. We can try, definitely try. This is O1 because the letter is at most 1,000 letters long, and then it just O1000. So this is O1. Unless we everyone we check it. Yeah, let's. Unless there are like a faster way to see whether a word is contained inside. Anyway, we first sort the original dictionary in such a way that the result is ordered first by length in descending order, and second by lexicographical order, in ascending, graphic in ascending order, if the length is the same. Then for each word in the sorted dictionary, we check whether the word is contained in the S. We return the first word that matches to S. Otherwise, if no word matches, we return empty string. So it's O n log n plus n, plus n. This is O n log n. This is O n times O 1000. And yeah, that's it. We hit 404 milliseconds, which gives us 60% ranking. Yeah, I'm still thinking. Maybe it's faster. Who knows? But we probably have to change, like instead of just a string, it has to be. Yeah, let's give it a shot. Maybe priority queue can work as well. I mean, it definitely it shall work. I'm gonna import keep queue, and let's do the exact same thing. Well, not exactly the same, but pretty much the same. 2. We don't change this, and we're gonna say heap equals for word in D, and then it's gonna be minus word and word itself. And we're gonna say heap q dot heapify heap. Let me say while heap if self dot contains s word will be heap q dot heap top heap. We're gonna return word. All right, let's try it. See if it works. Syntax error. I forgot to add this. Oh, that is not good. Why? It's not the word is not recognized. Is that what it is? I thought this is how you use the I thought this is how you use the Walrus. Huh? Let's see. Let's see what gets passed in. Oh, it does get passed in. Oh, shoot. Hold on. So we cannot do this. We have to say word equals this. Huh. Yeah. Yeah, there we go. And I'll pass. I'll say use heap. Should be faster. It's not really. Using heap, it's the same. So we have on here to heapify, but each time this costs log n, and this is n, so still n log n. It's still n log n. I think it's still n log n. It won't change. Do we have a solution? We do have a solution. We'll move in there, but give it a shot. Let's try this. Run code. It's good. Overall, yeah, it's the same performance using heap. Use heap. Same complexity. Similar performance. We hit for all and log n, and we hit 420 milliseconds at 58% ranking. All right, let's see the solution. Let's put this medium and brute force. Oh, iterative brute force. Oh, sorting and checking subsequence. And log in X without sorting. Oh, we have a winner here. All right, let's first see the sorting. And Boolean is subsequence. It's the same solution. We have a for loop on the outside, and if oh my god, if they're the same, j++. If they're not the same, I keeps going. How is this going to work? There's no other loop inside? All right, this doesn't make sense to me. So we're trying to see if y is in x, right? Oh my god. Is subsequence str is in s. Okay, so x is in y, right? So x is in y. So we run y on the outer loop. If it's the same, we increment. If it's not the same, we just keep going. Oh, okay. Oh, it's a better way. Yeah, let's change it. Let's change it. Let's do like solution 3. Just make it look nicer. Yeah, if we reverse it, it'll make it cleaner. I agree. I absolutely agree. So when I check whether word is in S, right? So all we need to do is just to go through for letter in S, right? Go through this, and we still need I on the outside. I'm gonna say if word I is equal to letter, then we can keep going. The letter will just keep going every time, right? And then when +1, and then the end, we're gonna check return. So I shall equal to Lambert. Yeah, I think this shall work. And oh, I can actually even make it shorter. So we can say sorted D, because we are iterating it. Sorted D, so it's going to be word S. All right, let's give it a shot. Index out of range. Why would index out of range? Well, it's because it's the same, and every time I'm going to check. I plus equal to 1, and I'm going to say I, also smaller than landward. Yeah, now we pass. Okay, so this, try it again. It's like a little bit optimized. See if it's any faster. Should be the same, similar at least. Oh, what happened? Oh, it's pending. Well, pending is fine, which means it hasn't been submitted yet. Why? Why are you pending so much? I want to know. Ah, dear Lord. Let's keep pending. All right, don't worry. So yeah, our solution is the same as this one. I mean, x is determined value, so it's fine. Okay, the last one, without sorting. Okay, what happened? Did we do it? Connection timeout. That is a new error I've never had before. What the heck? Connection error. Let's see. It should be fine now. Oh, we had a connection error. Oh, we still have connection error. Oh, wow. This is new. Wait, do I lose internet? I don't think so. Now I have internet. Everything works fine. It's a server. Ha! Anyway. Okay, we can skip the sorting and directly look for the strings x in the unsorted, such that x is a subset. If such a string x is found, we compare it with the other matching strings found till now based on the required length and lexicographic criteria. Thus, after considering every string in D, we can obtain the required result. Oh! I didn't think about this. Yes, this is true. We don't have to do it this way. Anyway, this is a better algorithm to find whether a word is in S. But we have no clue. It kept timing us out. Screw you. Why you time us out all the time? Yeah, so we cannot submit. Anyway, we still can do the next one. So we're going to have solution 4. Everything else, courtesy, everything else is the same as above. This is courtesy of the official solution. And we have solution 4, which we don't need. Exactly. No need to sort. Just compare the result. So we don't need to sort. We'll just say in D, the rest is going to be this. If contains, and then we say, how do we say? Res equals a word if len word larger than if len word larger or equal to len res and word is smaller than res. Else res itself. Solution 4. We fail. Why? Res and word if word is larger and word is smaller than res. Because nothing is smaller. Okay, so it's okay. So it's okay, split like this. If it's larger and then else, which means they're the same. Else word if len word is equal to len res and this and then else. Ha! Still not right. If this res equals word if len word is larger than res, else res equals word if this is the same length and word is smaller than res. Else res. How is this not right? Huh. A word in D. Yeah. Let's put this to make it more explicit. Nope. What's the logic? Oh, logic is wrong, huh? Then rest is 0. So if this rest shall equal to word immediately. Oh, you're returning. I know why. My goodness. No, return rest. There we go. Okay. Now we have solution 4 already. Oh. Oh, wow. This is faster. O n log n. 316 milliseconds, 71% ranking. Well, not sure. I mean, a couple of things, right? We have this, which is yeah, well, this one doesn't really matter that much. It's just here. It's easier. I mean, it's less code. That's probably why. And this is just on. Well, on times x. Okay, let's just be more specific. It's n times x. All right. N times x. This is also plus n times x. Okay, this is actually a little bit complicated. We have on is the heap file, and then we have n, and then every time we have log n, and then plus x. Yeah. This one is the same, plus nx. And this one is O n times x, that's it. Okay, let's take a look how long it takes for this one to run. Submit. 400. All right. So we just around there, 61% ranking. All right, we're done with all our methods iteration. Now we're gonna go read some comments. Comments. OM. So overall should be n times m. Yeah, n times m. Well, it depends, because m doesn't grow. Misleading. Oh, no. Former code interview resource here. Better than this? This is pretty good. Oh man, this is too much code. There's more than one longest. Default. Oh my god! Pollute my eye. All right, let's take a look. Sorting dictionary and without sorting. Hawkman, what do you have? Oh man, what is this? Is subsequence it? All right. C in it for C in X. I guess it actually works. No, this is yeah, this is not as efficient. But anyway, filter. Oh my God, filter. Filter. D, everything we check. After we check, put this, we sort this, and we key equals. Oh, we do a max with a key. Okay. Same this, so we can use filter. After filter, we plus this, and a key is this, minimum, no sorting. All right, that's cool. Oh man. State. Oh, this is like two gods is talking with each other. Where it is during iteration. Turns true. Not familiar with iter at first. Wow, there's something that he doesn't know. Anyway, iter. Iter takes the iterable object and returns an iterator with state that remembers where it is during iteration. C in iter turns true if the value in the iteration and updates the state to point to the next value. Return false when it goes to the end of the iteration. So they turn the S into an iter. Why? We can just for C in iter, C in X. Why do you want to use an iterator? To save space. To save space. Otherwise, you will. No, it doesn't save space. It doesn't save space. Because it will end, because it's all. So whenever it sees a false, this one shall return immediately. I don't know. What's the benefit of having iter? I mean, the benefit is lazy evaluation while you're doing this. If we don't do it, it's going to be C in S, and then for C in X, right? Again, why? And how does this even work? Hold on. For C in X, C in iterator. So C in X is each word. So for each word, we're going to check if it's inside here. If it's inside, we move iterator down. If it's not inside, we keep going down. Hold on. I think I kind of understand. It returns true if the value in the iteration and update the state. Returns false, it goes to the end, which means we're using this trick. So this one will return false when the S goes to the end. Oh my God, now I think I understand why I use iterator. Oh wow. Yeah, so basically what we want to see is for each letter in a word, right? We want to see if this letter is also in the S. And if it's in the S, I want this We want both to increment. If it's not in the S, we want the iterator to increment. But because it's an iterator, so if this one is true, then we're going to increment iterator and increment this one as well. If this is false, just iterator will just keep going, right? Evaluate the false, so it keep going until. Is that what the iter does? I actually have no idea. This just seems magical. I want to test it. Whatever it means, right? So we say S is A, B, C, D, E, F, G. How do we test it? So we're gonna say it equals iter C, iter S. So it is just an iterator. So we're gonna say for in range what 1, 2, 3, 4, 5, 6, 7. Print A in it. True, false, 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 false. So it will return false. And then what? So every time it's and then it goes into false. And instead if it's false, it shall keep going. 1, 2, 3, 4, 5, 6, 7. I did it 7 times. What is iterator now? Now stop iteration. It's just wait. How is this working then? It's if the value in the iteration, if the value is in the iteration, update the state to the next value. It turns false when it goes to the end of the iteration. But won't this return false? I don't understand. I do not understand how this one works. Let's have a solution 5. And we're gonna use Stephen-Pachman's idea. So it says it equals iter S. I'm gonna return all seeing it or seeing word. Of course it works. And then I want to dig deeper for seeing word. Print seeing it. Res equals seeing it. And then res this. And then we say res dot append res return all res, right? We have true. Okay, can't even separate this. Word. Yes. All right. So ALE, true, true, true. ALE, and S is this. So C is A, and A in iterator is true. Good. Going up, L. L in wait. It is like if it's not true, then it does not even return. Hold on. What the? This is, I don't understand. The iter function. Where is the built-in function? Here we go. Let's take a look. Iter. So the return iterator, the first argument is interpreted very differently depending on the presence of the second argument. Without the second argument, object must be a collection object. Suppose iterate OK, I must support a sequence protocol OK. If it does not support either of those, then type of erased. It's given the object must be a callable object, and blah 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 blah. One useful application is to build a block reader, for example, reading fixed width blocks. Okay, I actually used this. I implemented it somewhere in my other projects, but it didn't say about in. It didn't say about in iter. What it means is every time we call in iter, and if it's false, it will automatically go look for the next one. That is magic. Where is this even said in the documentation that you can use it this way? Yeah, you see, this one is just not right. We have true, so that's AP, and then the next P is not found, so we go to the end and it's false, and then everybody else will come out false. What is the, all right, what's in? Probably have to go here. Is that one of the, that's a statement, right? That's not a function. In. Oh my goodness. Syncfile, that's just too many of us in. In iter. Can I see anything? Ah, no. Bonkers. Yeah, what is this thing? If we call in an iterator, what does it evaluate to? It evaluates to true or false, right? And if C is in an iterator, then iterator goes to the next one. If C is not in the iterator, it forces iterator to go to the next one as well. I need Google on this. Like DuckDuckGo cannot work. Python in iterator. For loops. Oh, hold on. This is too weird. All right, I want to create a simple case. So I'm not sure if you guys know like why I'm so confused right now. It's just very weird. Like I don't understand. I don't understand at all. I think I'm gonna create this print A, B, and print B, right? And actually, it's not right here. And we do C. Oh my god. And print C. Okay. Oh. Oh no. Oh, I only evaluate once. Oh man. I want to see that it's actually. Maybe I can go iter directly. It's, oh, I know, because I use this. So if I don't use this, nope. A S for S in A, B, C. Is that correct? We're creating an iterator. Nope, it's not correct. What we're trying to do is I want to create an iterator with print function unmatched. Where? Okay, now A is an iterator, and then I'm not printing anything. So if I say next A, it will print, and then also do this next A, and then we're done. Okay, so this is good. So we have A, B, C, and we have evaluation in it as well. So we're gonna say for C in, let's see, an actual word. Let's say in AC, right? If I want to say res equals print C in A. All right. Okay, print C in A. So for C in this, C in A. So first one, oh, man, that is not. That should be because it should be the true, right? So hold on. We don't have any true coming out, and C in A, which means C is an A, and we try to be in A. A is iterator, so C in this. I think C in this shall A in this shall be true, right? And we get the first one, we get A out, and we actually is false. So C in A is false, right? You see, it's false. It's false. So it iterates into the next A, and then it's also false, and also false, and then it turns false, and then that this one is also false. So it does work this way, but I feel like this is a slightly inferior example. I was hoping the first one can print out as a true. All right, I'm gonna think about it more later today. So, but we're gonna end right here. But it's a very interesting use. It's a very interesting use, this one. I never encountered myself before, and I don't really think this is a good explanation. It is updated if a given set of characters have been visited with checklist. Yeah, I'm gonna take another look at this. Anyway, that will be it for today. I'll see you guys tomorrow. Bye. Adios.